We have seen, in the first part of this journey through the history and philosophy of science, that science developed into a social institution. The Enlightenment had, in spite of differences among the thinkers, paved the way for the modern period, based on the ideas of democracy, individual freedom, including free speech and the rule of law. But also the modern era would mean the industrial era, new social challenges, new questions to answer, and new disputes about what science is.
From 1800 on, we are into the sort of the modern period, and during that period there is more advances in science, but there is also a questioning of the whole Enlightenment project, and there is an ideologization, there is ideological struggles within science.
And this tragically ends with the Second World War. The main questions that have followed science throughout its history are still at the center of discussion. What constitutes true knowledge? Is there one science or many? Is there one uniform way of doing science or many? Is science social or politically biased? And can scientists study anything? The center of this discussion would, for the next more than 100 years, be the German-speaking world. The Prussian King Friedrich III wanted to make Berlin into a major capital in Europe. He therefore wanted to place a new university in the center of the city. Willem von Humboldt was an Enlightenment scholar and had been arguing for education reforms. In 1809, he was called by the King of Prussia to a post as education minister. He founded the University of Berlin in 1811. The university would become one of the most important universities in Europe. It was named Humboldt University of Berlin in 1949.
This room is special because it has certain figures of the history of the university and also of important figures of the time when the university was founded. And one of them is Willem von Humboldt, who had the idea for that university, and I think it's especially nice to have a picture by him here because one of Humboldt's main idea was to combine teaching with research. That's, I think, one of the ideas for which he is famous, that a university should be a place where research is done on the one hand, but the same people who do the research do the teaching.
William's younger brother, Alexander, would exemplify a universally educated man. He was an explorer, and in around 1800 he made long travels to Latin America, observing nature and culture, and pioneered the idea of seeing nature and culture as a whole integrated ecological system.
I think the fact that they chose philosophers to lead this university shows what kind of time that was and in how far and how much somehow this idea of this university is built on ideas.
The Humboldtian model of higher education was a comprehensive perspective on education, where studies and research are integrated, and students learn a wide range of subjects, both science, cultural knowledge and art, in order to support their individual education and development. However, Humboldt's ideas would be challenged from two sides. Those who did not think he took human self-development far enough, the idealists, and those that argued that science should be about explaining the natural world, not only reflecting on it, the rationalists. Mm-hmm. The main thinker within the idealist camp was Georg Friedrich Hegel. He became professor of philosophy at the University of Berlin and was the president of the university from 1829. Hegel argued beyond the thinking of Kant, further developing idealism and speculative philosophy.
Hegel argued that our thinking is based on our existence, and that means that our thinking is not only mental, it's also bodily. And we do not only have knowledge, we also have knowing.
He thereby criticized the rationalism of the Enlightenment. There is more to knowledge than pure thinking.
Hegel also argued that we as mankind is part of history and have a sort of a destiny related to the historical development. So our thinking is also embedded in the historical context that we exist within.
Hegel's philosophy went back to the ideas of Plato and Aristotle. It implied going beyond our immediate impressions and looking for deeper relations that govern the world we live in, which is basically dialectical and filled with contradictions.
Then we also have Hegel's desk. It was later found and then put in this room. And I think just a little funny anecdote about this table is that it has a little plate on it saying that's the desk of Georg Wilhelm Friedrich Hegel. And also it says at the very bottom, bitte nichts abstellen, which means don't put anything on it. And the funny thing is obviously that that's written on a plate which is put on the table. So it's a kind of pragmatic antinomy, which is funny because I think it demonstrates Hegel's thinking, which is somehow known for these kinds of practical antinomies to be at the center of all thinking.
Hegel's thinking would inspire the next generations of German thinkers, with a focus on how we can understand ourselves and the world as an integrated historical and cultural reality. Contrary to the idealism that developed in Germany, more rationalistic thinking developed in France.
One of the persons that came to take the rationalistic tradition of the Enlightenment period forward was Auguste Comte. He grew up after the French Revolution and he stayed in this apartment here in the last part of his life.
In contrast to the humanistic ideas of Humboldt and the idealistic ideas of Hegel, the French sociologist Auguste Comte developed a much more rationalistic idea of science, what he called positivism. Positivism, according to Comte, was a stage of knowledge development where all metaphysics was removed. It meant that knowledge is based solely on pure facts or pure abstract logic. He thought that mathematics was a science that had made the greatest advancements in terms of abstract knowledge, and argued that all the other branches of science, astronomy, chemistry, physics, biology, and sociology, should strive at the same level of abstraction, thus becoming positivistic. Furthermore, Comte's vision was a science that should be useful for society, and he even argued that science would take over the role that religion previously had had as a main reference point for society. Comte's positivism combined British inductive empiricism with Descartes' rationalism. The positivist method would imply doing empirical observation, and from them develop general abstract theories. It therefore went much further in theorizing than induction. The big ambition for science would be to describe things in mathematical form. Comte believed that the more mathematically precisely a phenomenon could be described, and the simpler the theory was, the closer it was to truth. Astronomy had, according to Comte, almost reached the positive stage. Social science, on the other hand, lagged behind. In economics, positivism inspired the development from classical economics, based on empirical observation, to neoclassical economics that was described in pure mathematical terms. Comte's countryman Emile Durkheim would use this method in his sociological studies, revealing the nature of social structures. Durkheim developed social functional theories on how family structure, religion, industrialization, and urbanization impact our lives.
In the mood of Auguste Comte, and also inspired by David Hume, the British biologist Charles Darwin in 1859 published his book The Origin of Species, and in this book he offered a completely new explanation of how species had developed, denouncing creationism and arguing for evolution through natural selection.
Even though there were similarities between scientific discoveries in different countries, there were also differences in how science was perceived.
Why was British science so occupied by looking at natural things and developing new theories about natural things?
We can observe a contrast between the continental way of thinking, basically the German way, and the British way. Although science itself was international, the philosophers of science was concerned about different problems. And what the British taught us was the simplicity of science. Science is built on observation, so we have to go out in the world, observe it, collect data, and then we can build our theory as simple as possible on those data. And the theory of evolution is a good example of this, because it's basically a very simple theory.
Now, several discussions in the German-speaking world started. Was there one science for all disciplines? Or does each discipline have its own science? Are they governed by the same principles? Is all research science? And is there more than one way of doing science? The dualism between natural science and human science was highlighted in this new dispute called Methodenstreit, or the dispute on method. It was a dispute where Austrian philosophers and scientists reacted against German idealism and historical orientation. The dispute was mainly related to the study of the economy and society. Vienna, the capital of the Austrian Empire, had become one of the main intellectual centers in Europe. Here, philosophers and social scientists started to adopt the positivistic way of thinking, while their German counterparts were following thinking from Kant and Hegel.
More or less, it was a direct or indirect reaction to German idealism. They called it school philosophy, Schulphilosophie, in the tradition of Kant. And Kant played a major role as a subject for criticism regarding, is there any a priori knowledge, for instance, is there a categorical imperative?
Kant had exemplified how we can know things a priori, that is, before they are observed. The categorical imperative as an ethical norm, that you shall act so your action towards others can form the model of how others should act against you, is a principle we can know is reasonable without observing it. Austrians agreed with positivists that the foundation of our thinking should be observation. However, in Germany, and in particular at the University of Berlin, scholars still argued that at least humanities and social sciences were different from other branches of science.
In what becomes so-called Methodenstreit between German and mainly Austrian scientists, is this discussion: is there one way of doing science, or is science really many things? And also the discussion of whether science in Germany is the same as science in France or in England or in other places. So does the historical context count in the way we are thinking about things?
Because there was also reactions in the 19th century to German, this grand way of thinking of Hegel, who tried to encompass everything, also history, in one unified system.
Perhaps one could say that in this Methodenstreit, natural science could be left out because that was not that controversial, whether nature looked like that or not. But in all other fields, then the Germans would, the so-called historical school in Germany would claim that there is a particular way of thinking at a particular point of time, and that influenced the way we look at things.
German scholars were arguing for a special foundation for the human and social sciences. Among these was Wilhelm Dilthey. From 1882, he was professor of philosophy at the University of Berlin. Dilthey became convinced that the study of nature and the study of man and society never could be the same kind of science. While we can explain nature, we can only understand the human world. He thereby established the interpretivist position in social science.
His way of dividing science into natural science and human science was a way of dealing with this complexity that the Methodenstreit had created. That we could, on the one hand, natural science we could agree rather easily on the method of how to do natural science. In human science, we need similarly to agree on some way of doing science. Causality is the key thing in natural science, but understanding and meaning and interpretation is the key thing in human science.
To Dilthey, still natural science was a kind of simple kind of science, unproblematic, which didn't need any philosophical effort to understand.
Thereby a new methodological dispute in science occurred, that between the positivist and the interpretivist tradition. However, the idea that science is many things also provoked new attempts to define the unity of science. Now something new happened that would impact the idea of scientific knowledge. And again, this new insight came from physics. Similar to how Newton's discoveries had inspired philosophy of science in the 18th century, the new physics influenced philosophy of science in the 20th century. And again, it started in Cambridge.
Newton's laws ruled physics for 250 years. But at the beginning of the 20th century, something happened. People started investigating the atoms, and the atoms came to be the most important subject of study at all in natural science, because atoms explained physics, they explained chemistry, they explained biology, geology, cosmology, and so on. And within the atoms, the laws of Newton didn't apply. And now, here in Cambridge, we could concentrate on Paul Dirac, who did his very special contribution. And this is the way he worked. He started by mathematical reasoning. He started by thinking, how should nature look like? And he developed a beautiful equation describing mathematics as he thought it should be. Something very strange popped out of this equation, namely that for each particle there existed an unknown particle called its antiparticle. For instance, for electrons, there was an anti-electron. Nobody had ever observed an anti-electron. So this was a purely mathematical, or a purely result of his mathematical reasoning.
The new insight into atoms and electrons mobilized scholars around Europe, and by the 1920s, the University of Berlin became the center of the new thinking in physics.
And the first half of the 20th century was a time of the big revolutions in physics, the big groundbreaking theories like the special theory of relativity, the general theory of relativity, and quantum mechanics. And those theories are associated with names like Albert Einstein, Max Planck, Erwin Schrödinger, and Heisenberg.
Why did all these important physicists come here to Berlin?
All of them came to this university and had a position here together in the 1920s. So this tells us a lot about the prestigious university this was.
If we look at this breakthrough, this revolution in physics, is it relevant also in the history of science to look at what was happening? Did it impact the development of science in general, the way that physics started to look at the world in a new way?
You can say that the German universities, based on the ideas of Humboldt and Enlightenment, was a place where people were not only discussing physics but also philosophy. And it's obvious that philosophical thinking were important for the physicists to really do the revolutionary changes.
Modern physics challenged some of our basic conceptions of time, space, and causation, as was illustrated by Werner Heisenberg. He formulated the uncertainty principle, which says that the more precisely the position of some particle is determined, the less precisely its momentum can be known, and vice versa. And Erwin Schrödinger used an example of a cat that is both alive and dead at the same time to illustrate some of the features of waves in quantum physics. The new breakthroughs in physics were neither based in experience nor in observation. Rather, the process of developing this knowledge was beyond the discussion of induction versus deduction. In the same way as Berlin became the center of new thinking in physics, Vienna became the center for new thinking about science, based in the insights from physics. In Vienna around 1900, there was tremendous experimentation with new ways of seeing things. Art, music, literature, architecture were all searching for new forms and rules. Both in science and art, one was starting questioning the rules of the game. Both science and art perform and create knowledge within conventions. It was therefore argued that one should rethink these conventions. The people who started to do that were called Modernists. These Modernists were looking for new formal procedures and rules to govern the way we think and look at things. The person who brought some of these ideas into philosophy was Ludwig Wittgenstein.
Wittgenstein designed this house for his sister Margrethe, and it's a good illustration of his philosophy and thinking that he formulated in this small book, Tractatus, which had a tremendous influence on philosophy and on science. The parallel is that in Tractatus it says we need to start philosophy on a new ground, removing all old metaphysics, all unimportant things, and come back to the basic principles that philosophy should be based on. And it's the same idea that you find in architecture at the time.
Wittgenstein presented what has been called a picture theory of language. Using the picture as a metaphor, one can think that a picture can be true, in the sense of not manipulated, and still not the whole truth. The picture shows one angle of things and leaves others unnoticed. This is also the case with our picturing of the world. We see certain things, but not necessarily everything. But how can we be sure that what we see is true, if not the whole truth? Here Wittgenstein argues that in order for a sentence to be true, it has to be built up by elements that are each true.
Wittgenstein realized that philosophy is not only just about to get the right understanding of the phenomena. Philosophy is also about the very language that you use to understand the phenomena. And he realized that a lot of the problems of philosophy were not in the way they think about the phenomena as such, but in the way they use language to express this thinking.
Wittgenstein's ideas inspired scientists. Could a new foundation for science be found based on both the new insights from physics and Wittgenstein's new insight into language? This was a question asked by a group of scholars at the University of Vienna that became known as the Wiener Kreis, or the Vienna Circle. The Vienna Circle called themselves neo-positivists. They thereby gave some reference to Auguste Comte, but at the same time they wanted to bring this tradition forward. They agreed with Comte that science should be anti-metaphysical and be based on observable facts, but should also take into account logic and language.
It was still anti-metaphysical philosophy. It was the commitment to the exact sciences and methods, but it was also the inclusion of modern language analysis. There was this claim to combine or to have a coverage between the old tradition of rationalism and empiricism. And in the term logical empiricism, you have the same tendencies. Both tendencies are coming together, but not in a systematic way. So that these two poles were really significant for the intentions, different intentions within logical empiricism.
But the Vienna Circle and sort of the logical positivist or post-positivist that has sort of been called very much later, it's very often seen as a sort of proclaiming the unity, the sort of science.
Yes, one point was, is there more or less a unity of all sciences? And regarding methodology and epistemological claims, there was an agreement that there shouldn't be this absolute divide between humanities and the natural sciences.
In the Europe of the 1930s, strong political polarization had an impact on the scientific debate, and by the mid-1930s, most of the members of the Vienna Circle had emigrated from Austria.
We know that most members identified themselves with leftist or liberal positions in the wider public. They were driven out because of their philosophy and because of their personal political attitudes. And there is a family resemblance between scientific philosophy and the emergence of the young republics in Europe, democracies and republics.
So, how can we summarize how the Vienna Circle and neo-positivism took the new insights from physics and language theory into account? First of all, they did not make a doctrine or normative theory of how to do science. Secondly, they demanded that all thinking is based on observable facts. And thirdly, they were concerned with how we construct sentences. Their objective was to avoid integrating metaphysical assumptions in our use of language. Parallel to the Vienna Circle, another philosophical position developed. This position also argued for the unity of science, and it got its inspiration from Vienna, even though it mainly developed in Germany. This new philosophical position was called Phenomenology, and it was quite different from neo-positivism.
Phenomenology was developed by Edmund Husserl, and he got some of his most important ideas from his teacher Franz Brentano here in Vienna, where Husserl was a student. Then Husserl brought those ideas to Germany and developed them, first in Göttingen and then in Freiburg. And the main idea was to unify the philosophy of the subject and the philosophy of objectivity.
And how did he do that?
He did that by a core concept called intentionality, to stress that the subject or consciousness is always directed towards something, which is the object. And this directedness he calls intentionality, as Brentano had done.
Did Husserl's phenomenology influence his view on science?
Yes, many scientists between the wars in the 1920s and 30s took up phenomenology as a basis for their own thinking.
Husserl's students started to develop phenomenology. The idea of putting the individual life world in the center of all thinking inspired both political and ethical theory. The most influential student of Husserl was Martin Heidegger.
Martin Heidegger was an assistant of Husserl's in Freiburg, and he developed phenomenology in his own way, moved a bit away from this strict objectivity of Husserl, taking into account the manifold ways that a human being has in their relation to the world and to itself, and developed some what we could call a basis for more existential philosophy.
Heidegger published his main work, Being and Time, in 1927. The work was inspired by both Husserl and Hegel. Here he argued for the need to address the ontological question, what is the nature of things? And the most fundamental ontological question is, what is being? Heidegger argues that being is something preconceptual, hence pre-scientific. It implies a limitation to the ambitions of science, and to the idea that instrumental reason can give us answer to all kinds of questions. While many of the neo-positivists had tried to develop science in a logical and abstract way, phenomenology had tried to found science in more existential thinking. The phenomenology scholars had been increasingly worried about how science had become instrumental. Edmund Husserl died in 1938, but managed to publish in 1936 a book where he strongly attacked the way science had developed.
In the 1930s, Husserl started worrying about how science developed into more and more abstract science, more and more mathematics, more and more concepts which were far removed from the life world of ordinary people. Because Husserl was more and more thinking about the life world as a subject for thinking. And he thought that science was moving into a crisis because it lost contact with the world of ordinary people.
Husserl's warning against science turned out to be rather prophetic in terms of what was to happen during the Second World War. Science was used in the ideological battle with terrible consequences, both through its experiments on human beings and the development of new weapons.
Robert Oppenheimer was professor of physics here at the University of California in Berkeley, and he is called the father of the atomic bomb.
During the Second World War, he became leader of the Manhattan Project, a project with the intention to develop nuclear weapons.
The nuclear weapons testing program.
The first atomic bomb was detonated on July 16, 1945, in the Trinity test in New Mexico. The same kind of bombs were dropped on the Japanese cities of Hiroshima and Nagasaki on August the 6th and the 9th in 1945.
Oppenheimer later remarked that he was aware that what they had invented would change the world, and also that what they had invented could destroy the world. Today, scientists are engaged in trying to prevent that this happens again.
In the two first parts of this journey through the history and philosophy of science, we have seen that science started in ancient times by trying to understand the world. Gradually it had been able to explain at least part of the world and show how man can utilize the resources and forces of the world. By the mid-20th century, science had also demonstrated that its knowledge could be used to destroy the world.